Hi there, welcome to this lesson on further pure mathematics 2, and in this lesson we're looking at de Moivre's theorem. In the last lesson we learned that if you've got two complex numbers and it could either be written in exponential form or modulus argument form, then if you multiply them together, you multiply the two moduluses and you add the two arguments. If you divide them, then you divide the two moduluses and you subtract the two arguments. In this lesson, we'll be looking at what happens if you have a power of a complex number. So for example, let's say the power was 2. And r cos theta plus I sine theta is just the standard complex number. If that was squared in modulus argument form, it's the same thing as re to the I theta squared if I write the complex number in exponential form, which is equal to re to the I theta times by re to the I theta. I can just use the normal index laws at this point. There is no problem in this instance. And that will give me r squared e to the I2 theta. Rewriting that in modulus argument form gives me r squared into cos 2 theta plus I sine 2 theta. So when you square a complex number, we've squared the modulus and we've done the argument times by the power. We've done theta times by 2. This idea generalizes into what's called de Moivre's theorem, where if you have the complex number r cos theta plus I sine theta to any power n, then the modulus is taken to the power of n, and we have to do n times by the argument, n times by theta. Okay, let's have a look at an example. Simplify this expression. I'll let you have a go yourself first, but before you do so, do just take care with the complex number on the bottom. It isn't written in the standard modulus argument form. This minus does need to be changed to a plus. I'll let you have a go yourself first, and when you're ready, come back to me again. Okay, let's have a look at this. So as I said, we need to change this minus to a plus, and the way we do that is always the same. We multiply the angle by -1, so that we get minus pi by 3. The cosine of theta and the cosine of minus theta are exactly the same as each other, so there's no problem with the cosines. But the reason why we've done it is because of what happens to the sine. The sine of theta is equal to minus the sine of minus theta. So if I change this to minus pi by 3, then the minus in the middle of the brackets also changes to a plus, which is what I need to do to write the number in modulus argument form. Now I can use de Moivre's theorem. We would normally be doing the modulus to the power of 5 and the modulus to the power of 4, but the modulus is just 1 in both cases. So we've got 1 to the power of 5 and 1 to the power of 4, which is just 1. For the angle, for the argument, we need to do 5 times by pi by 3, which is what we've got on the top, and 4 times by minus pi by 3, which is what we have on the bottom. And what we're then going to do is use this rule for dividing complex numbers. That if you're dividing complex numbers, you divide the two moduluses and you subtract the arguments. Now, we've just got to divide 1 by 1 for the moduluses, which is just 1. Subtracting the arguments gives us 5 pi by 3, take away minus 4 pi by 3, which becomes 5 pi by 3 plus 4 pi by 3, which simplifies to 3 pi. The cosine of 3 pi is -1, the sine of 3 pi is 0. So this complicated expression simplifies to just -1. Okay, second example. We've got a complex number written in Cartesian form, 3 minus root 3i. We need to do it to the power of 6. First of all, we'll need to change the complex number into modulus argument form. So you need to find r, we need to find theta. I'll let you have a go yourself first. Pause the video, come back to me again when you're ready. Okay, let's have a look. So to find r, we'll do the square root of 3 squared plus root 3 squared, which is 2 root 3. To find theta, we'll do inverse tangent of minus root 3 divided by 3, which is minus pi by 6 radians. This complex number would be in the bottom right-hand corner if I drew an Argand diagram, and minus pi by 6 is the angle made with the positive real axis. I've chosen to change this to what would be the positive value if you went anti-clockwise all the way around, which is 11 pi by 6 radians. You don't actually have to do that. We could have left this as minus pi by 6. The angle does have to be the angle with the positive real axis, but you could go with the minus, you could go with the plus. It really doesn't matter. Both will work fine. You'll see in the next question that you can get an issue when the angle that you get is not with the positive real axis, but we'll look at that in a moment. So having changed this to the positive value, 11 pi by 6, going anti-clockwise, this would be the complex number written in modulus argument form. We then will use Demoivre's theorem, so we'll do 2 root 3 to the power of 6, which is 1728, and then timesing these arguments by 6, we'll get 11 pi. The cosine of 11 pi is minus 1, sine of 11 pi is 0, so that will simplify to minus 1728, and that's the answer. Okay, example 3. Again, we've been given a complex number in Cartesian form. We want to do it to the power of 5. We need to find the complex number in modulus argument form. This time we need to take care with theta. Minus 2 root 3 minus 2i will be in the bottom left-hand corner of the Argand diagram. And when we find the angle, it won't be the angle with the positive real axis. So take care when you have to find theta. But I'll let you have a go yourself first. Pause the video, come back to me when you're ready. Okay, let's have a look at this. No problems with r. R is the square root of 12 plus 4, which is root 16, which is 4. To find theta, we do inverse tangent of minus 2 divided by minus 2 root 3. And the calculator gives you pi by 6, but it's important to know where that pi by 6 is. And this time we really do need to draw an Argand diagram. And maybe it is safer always to draw one. That's where the complex number minus 2 root 3 minus 2 would be. And the pi by 6 that we've just found using trigonometry is that angle there with the negative real axis. We need the whole of this angle coming anti-clockwise from the positive real axis. So that'll be pi by 6 plus another 180 degrees, or plus another pi radians. And that will be 7 pi by 6 radians. So theta doesn't equal pi by 6, it is 7 pi by 6 radians. Now we can write the complex number in modulus argument form. 4 into cos 7 pi by 6 plus I sine 7 pi by 6. Doing that to the power of 5 means we'll do 4 to the power of 5, which is 1024. Timesing the angles by 5 will give us that. Cos of 35 pi by 6 is root 3 over 2. Sine of 35 pi by 6 is minus a half. And that's probably the simplest way of writing down the answer. 512 root 3 minus 512i. Okay, example 4. So we've got a complex number on the bottom of a fraction here. To begin with, you just don't worry about that, but you deal with it being on the bottom of a fraction later on in the question. I'll let you have a go yourself first. Pause the video, come back to me again when you're ready. Okay, as I said, we'll begin just by considering this complex number on the bottom. Z equals minus 2 plus 2 root 3i. We'll find r in the normal way, which is root 16 again, which is 4. Theta in the normal way, which is inverse tangent of 2 root 3 divided by minus 2, which is minus 2 pi by 3 radians. Now, on an Argand diagram, which I have drawn this time, it'll be down here. The minus 2 pi by 3 is the angle with the positive real axis. You remember in the earlier question, I chose to write down the positive angle going anti-clockwise. That isn't necessary. I often choose to do it, but things work equally well if you go clockwise from the positive real axis, as long as you do remember to keep the minus. So it's minus 2 pi by 3, not plus 2 pi by 3 radians. That gives us the modulus argument form of the complex number, 4 into cos minus 2 pi by 3 plus I sine minus 2 pi by 3. We need to find the power of 3 of that using Demoivre's theorem. 4 cubed is 64. Timesing these by 3 will give us minus 2 pi. The cosine of minus 2 pi is 1. The sine of minus 2 pi is 0. So that does simplify to 64. And it isn't up until this point that we worry about it actually being a fraction, 1 divided by that. So the answer is actually 1 divided by 64. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 31 and have a go at exercise 3C. Thanks very much for listening, and cheerio.